Hello and welcome to this Innova Systems webinar with me, Adam Rose. In this video we're going to have a look at some of the advanced sheet metal tools you can use within SolidWorks. So first of all I'm going to switch over into the software and we're going to have a look at actually what we're going to create today. So I'm going to open something up from my recent documents. Here you'll see I've got this coffee table opened up. While this isn't particularly a very complicated model in terms of its geometry, the kind of tools we're going to have a look at using are the more complicated ones for the sheet metal functionality. So we're going to have a look at things like the lofted bend tool and the swept flange tool, as well as how to create cuts over bend regions like this using the unfold and fold regions or normal cut options. We'll also have a look at how to maintain symmetry within the design, and also creating multi-body sheet metal parts where you've got several bodies within one model, which then you can take on to use into a drawing and create different drawings of each one. So I'm going to start off with this particular model. It's just a sketch really, and it just saves me from sort of creating that over and over again. So I can start from this. Now this sketch has just been created like normal on a 2D sketch plane. You'll see it's created on the front plane here. I'm going to use that sketch to create a base flange, which is going to actually start off this design. So it's picked up on the settings I've used last for this particular one. I'm going to have quite a large bend radius on the corners of this table because I want it to have quite a nice aesthetic look. The thickness of the material, well, I've given it about 5 mm in thickness, just again to make it look a bit more substantial. I'm also going ahead and I can change the direction 1 settings, which actually adjusts how thick the thing is actually extruding. Because I want to maintain the symmetry within this design, I want to go ahead and make sure that it is set to mid-plane, and then I'm going to send it out by 600. And I'm only modeling half of this design to start off with because I may as well just go ahead and mirror it over later on. So now that I've created the kind of beginnings of the table, I'm going to go ahead and actually create a sketch bend, which is going to create the sort of underside region here. I could have done that all within the first sketch, but I'm just doing this just to show the kind of sketch bend functionality. So I'm going to draw a sketch on this face just here. In order to insert a sketch bend, we need to insert a straight line across the model where we want the bend to be inserted. The position of this bend is going to be positioned based upon a point I had in the original sketch. So at this point I just need to show that original sketch just by clicking the glasses. And you see there's our point. You'll find it quite hard to select points like this though if you're looking straight on sometimes. So it's best just to rotate around to an angle a little bit. Okay, then it becomes a lot easier to select that little point there, and you see that fully defines a sketch line. Okay, so now I can actually exit out of this sketch. So once I've created the sketch line, I can then hide away the original sketch, and then I can use that sketch line to create my sketched bend. So just select the sketch on the left, click the sketch bend tool, and this little box pops up. In here, we need to select what is the fixed face. Now, we're going to bend this face just here. While it is, at the moment, one complete face, we're choosing which side of this face we want to bend, or which side we want to stay fixed, rather, while the bend is then produced on the other side. So I'm going to select this side to stay still. And you'll see a little black dot appears in the position where we click. So that means this side of the model is going to be bent over underneath the design. If I just flip this direction button, it will then be flipped in the right direction for me. So 90 degrees, I'm going to bend it around to, and I'm using that default bend radius I put in the first place, which was 90 millimeters. Okay, and that produces quite a rounded corner on there. Okay, now what I'm going to do, because I'm looking to maintain symmetry within this design, is I'm going to mirror over this sketch to the other side of the model. So if I just go ahead and select the mirror tool. If I want to mirror the whole sheet metal design, but actually join up with the original body, I need to select one of the faces of the design to make sure it's right down the middle of the model. And then I'm going to go ahead and use bodies to mirror because I want to mirror the whole item as a solid. Okay, now you'll notice here that we've got quite a substantial gap in the middle there, and that's because of the sketch bend and the position we've got it relative to the model. So if we would just go back into that feature, we can have a look at the settings. At the moment, it's set to bend center line, which positions the bend over the center of this line we've put in on here. If I put it so it's material inside of that bend line, it's going to reposition that bend, which you'll see actually pulls the two areas of the model closer together there. So by adjusting those kind of settings, you can actually make sure that your sheet metal part ends up the right form. Okay, the next thing I'm going to do is to insert some feet onto this particular model. In order to do that, I'm going to use one of the more advanced sheet metal tools, the Lofted Bend tool. It's like a normal loft within SolidWorks. First thing we need to insert is two sketch planes. So the first sketch plane is actually going to be the face on the underside of the model. I then want to insert a second sketch plane offset from that. So I'm going to insert from the reference geometry a new plane which is offset by 70 millimeters down from the bottom of the model. Okay. So I'm going to have one sketch on each of those planes. The idea with the Loft tool is it allows us to create a blend between two different shaped sketches. For this particular example, I'm going to do two different size sketches. So I'm going to do two circles, both at different diameter values. So I'm just going to add some dimensions first of all for this first sketch. Okay, in order to get that in the right place. There we go. And that will put that in the corner. And then also, because it's a sheet metal design, need to leave a region for the model to unfold from. So I need to put in a slight gap on this sketch. In order to do that, I'm going to use my construction lines. And if I just draw a construction line across the model and then back out to the edge again, it just gives me somewhere to actually trim away. So if I just trim away this little region in here using the trim tool, I can then just dimension the angle between these two lines just to make sure that it's fairly consistent. So I'll put that at 3 degrees. That gives me a small gap just to unfold the model from. Okay, having drawn out the first sketch, I can then go ahead and draw the second one. The second one is going to be positioned in exactly the same place as the first. So it's a case of actually inserting your next sketch. This time it's going to be slightly smaller. Okay. And then with the centerline tools, I'll just make sure it's the right size. And I can pick up the references from the original sketch to make sure I'm getting it the right size. And then again, I'll just trim away the excess. And possibly I might just increase the size of this leg slightly, just to make it slightly bigger there. Okay, so with the first two sketches drawn out, I can then go ahead and actually loft between those two. Unfortunately, with the sheet metal loft tool, we can't do any more than two sketches. So in order to insert it, we go to sheet metal, click the Lofted Bend tool, and then we need to select both our profiles. And it doesn't matter which order you select them in, or where you select them on the design. It should auto pick them in the right areas, and it should line them up based upon the region they're unfolding from. So you've obviously got to make sure your sketches line up approximately in that area, otherwise you're going to get twist. This thickness of 5 millimeters, well, I'm going to put that down to 1.5 so that it's slightly smaller. Okay, and I'm also going to change the bend lines so that we've got 6 in here. Okay, flipping the actual material means that we can then make sure it's either on the inside or the outside of this region. Okay, I'm going to put it on the outside there. You'll see there isn't an option to merge results on this one, so we're actually creating a separate sheet metal body here. You'll see now the cut list has got two items in. Okay, the first one being the foot, and the second one being the actual table itself. So having inserted that first one, I then want to create a bit of a cut out of this leg. Now in order to insert that, I need to first of all make sure it's in its flat form. Now obviously you could go and actually go into the flat pattern here and unsuppress that. But when we go ahead and actually suppress it again, any cuts that we insert will also be suppressed at the same time. SolidWorks has got a tool for actually doing specifically this kind of thing. It's using the fold and unfold tools. So the first thing we need to do is unfold the model in order to put it in its flat form, so then we can create a cut and fold it back up again. When we do it using this technique, we don't lose any of the actual cuts that we create or any of the features we create when we go through the feature. So in this particular flat form now, you see we've unfolded it. We can then go ahead and create our sketch on this face because it's now completely flat. Okay. So just create a very quick sketch on there. I'm going to make sure these two lines are parallel to one another. And I'm going to put in a few dimensions just to control the approximate size. Okay, I've got the model to about this kind of size. I then want to mirror it over to the other side to make it quite a symmetrical design again. So I'll put a center line right up the middle, using both the midpoints across both of those arcs. And then I'll use the Mirror Entities tool, selecting that region of the sketch and mirroring around the center line that we've got on the design. I also need to make sure that in this region at the top here that I've got a very slight gap. Okay, now there's a reason for that. I'll just delete this sketch relation and just pull it down. Because we unfolded it from this edge, we also need a little bit of the edge left over to fold it back up based upon it as well. Because we need to maintain that reference in the design. So I'll put in just a 1 millimeter gap there, which should just give us then the smallest edge to fold it back up based upon. What I'm going to do then is I'm going to go ahead and create a cut through the model using the extruded cut tool. You'll see currently it's set to blind, but we can use this link to thickness tick box to make sure that the thickness we're cutting through the model is the thickness of the material. It's a bit like doing through all or up to next. That cuts away from the model. And then we've got to use the fold tool. Now it's important when we're doing the fold tool to use the same edge as the fixed face or the same face as the fixed face as we did originally to unfold it. Otherwise you're going to find your model will move in the graphics area. Okay, it will rotate around 90 degrees or something like that. Having folded the leg back up again, you can see there we've got the design, actually how it would be manufactured and the form it would be manufactured if it was in real life. Now I've created the first leg, I want to mirror it around the design and create copies of it. So if I go to use the mirror tool, this time I want to select one of the planes in the design, and again I'm going to use bodies to mirror, but this time merge solids isn't turned on, so it's not going to join together these two items because there's a gap between them. Okay, I'm then going to do the same thing across the model the other way and mirror both of these two items to create 4 legs. Having gone through that process, I'm just going to create a bit of an overlap now, which will, in this region, just allow me to maybe put some bolts in later on, just to secure the two halves of the table where they come together. Now in order to do this, we need to first of all put in a sketch. I'm going to put a sketch on this face It's just going to be a straight line sketch across the design. Using the Smart Dimension tool, I'm going to dimension myself 15 millimeters from this edge. Having put in this line, I can then use this line to insert a jog. If you go to the sheet metal toolbar, you'll see the jog tool at the top, just above sketch bend. When you select the jog tool, very much like the sketch bend, you've got to select a fixed face, which side of this line you want to jog. So I'm going to select this side to stay still. You'll see our default bend radius of 90 millimeters is way too big for a jog in this region. So I'm going to tick the tick box to not use the default bend radius. I'm going to set this to 3 millimeter jog. You'll see then it comes down to a more reasonable size. I can then flip this to make sure it's going the opposite way underneath the model, and then I can put myself in an offset. Now the offset you'll see is measured from the top edge here to this line just here. Okay, but we can adjust that based upon these three selections, which adjusts the position of the actual item. So if I put it to this one, you'll see there's a very small gap between. The fixed projected length tick box, well, that either fixes it so that it lines up with the edge that we've got just here, or so that it is bending it and actually maintaining the length that it was originally. So it's slightly shorter when we've actually bent it. Okay, I'm going to keep fixed projected length turned on. And I'm going to adjust my bend position. You'll see by selecting these boxes so that the bend is positioned outside. By adjusting the jog angle, we can also adjust the shape of the jog as well. So I'll put it to 30 degrees there, and then we can position the jog so that it's going down at more of an angle. By hitting the tick, that creates my jog. And then I want to extend this face so it goes underneath the model. Now, in order to extend this part of the design, I need to add an extra sketch on. So I just select this face, click the sketch button, and then go ahead. And if I click normal to again, it will flip me around to the other side. And I'm going to draw out a rectangle, which is positioned off the edge of the model there. Okay, I'm going to take it right down to the bottom, and then I'm going to dimension it from both sides at 50 millimeters. Okay, that will just give me a small overlap between these two regions. Now, however, in order to insert the item in this region using this sketch 21 that I've created, I need to use the base flange /tab tool. You'll see that it's /tab. Now, the tab section of this allows us to add an extra tab onto a sheet metal part of the design. So you just draw out your item using a sketch, select the tab tool, and as long as you've got merge results turned on and that it is actually touching the original design, you'll be able to create an extra tab which will be joined onto your sheet metal part. So there's the tab that I've just created, the little overlap in that region. And later on possibly we could put holes through there if we wanted to. Now for the next part of the design, I want to put a cut through this region in the bend itself. Now much like this one, in order to put the cut in this region, we have to use the unfold and fold tool. And that's the first way I'm going to do it. So if I click unfold, this time we've got a fixed face being the top of the model. The bend to unfold just being this single bend here. However, if we click collect all bends, it flattens out the whole model. Okay, so that's flattened out this region. I've already got a sketch created for this particular area of the model. I'm just going to go to my design library. I've got a block that I've created earlier on, and I'm going to drag it into the model to position it over the design in this region. That's entered the block into a sketch, which if I then select this sketch, I can then create an extruded cut through the design using it. Okay. I'm going to put the item so that it's set up to next, And using my feature scope, I can actually select which bodies I want to cut through. So if I untick auto select, I can manually pick just to cut through this body just here. I'll hit the tick and that will then cut away this region with that logo. Obviously then I need to do what I did before, click the fold tool, make sure I've got the same fixed face as the first time and click the bend just here, just to bend it back up again. However, that's not the only way to do that particular technique. There are other ways to achieve the same thing. If we draw a sketch on the top of the model just here, looking straight down on the design, I draw a rectangle out. I'm going to show you later on what that will actually create. So I'm going to position this so that it's about 65 millimeters from this edge. Okay, and about 15 in thickness. And from this edge, I'm going to position it so that it is 50 millimeters. I then want to mirror this cut over to the other side as well to maintain that symmetry. Using mirror entities, I'll pick up the cutout, I'll mirror it around that center line there, and that will create two of those. If I then try and create an extruded cut through the model, and I just set it to up to next, for example, you'll see that the cut in the preview goes through the model at an unusual angle, an angle that you wouldn't get if you're going to produce this and actually manufacture it and bend it up yourself. Okay? It shows that the actual cut's been created after the bend's been put into the design, which obviously is not the way around you'd do it for real manufacture. If we tick the normal cut option though, that gets rid of any problems, and we hit the tick, and you'll see that then all of the edges of that cut are maintained normal to the face of the model. So you can just use the normal cut option to get around any issues and produce some cuts quite quickly in any bend regions. On this table now, I'd like to insert just some cup holders on the particular design that I've produced. If I go to my design library, in my forming tools folder, I can insert some. Now in previous webinars, we've actually shown how to insert the forming tools. What I want to do in this particular webinar though, is I want to create my own. I'm going to modify some of the ones that have been created in here. You'll see if I open up when I drag this circular emboss into the design, that it's not very big in size. I want to maybe slightly size up particular size of this in the design. Okay. So I can actually open the circular emboss up to have a look at how it was created. You see if we roll back through the design, most of these features start off with a boss extrude. Okay, and that is just for the feature, the actual shape of the emboss to sit on. We then insert the fillets over the model, okay, on both sides, and then this region here is cut away, and that leaves us with this filleted edge on the outside there. Okay, now if I want to modify the shape of this item, I can just double click and I can adjust some of the dimensions. So I'll put this one to 11 millimeters. I'll size this up to 60. Okay, and I'll just hit Control and Q to rebuild. And then I want to remove this fillet. I'm also going to size this one up. We need to make sure that any of the fillets we're inserting are larger than the thickness of our material. So that radius of 5 millimeters, I'm going to size it up so it's larger at 10 millimeters in radius. Okay. And there is the emboss that I want to create to use as a cup holder on this small coffee table. So I'm going to save this design. Okay, and I'm just going to save that over an existing model. I can then switch back to my assembly. If I then try and drag this item into the graphics area, so I'll just move this out of the way. If I just drag that in and drop it on the model, you'll see it comes up with the forming tool feature. In here we can flip the orientation of it by clicking Flip Tool. We can change which configuration we're using if we've got several configurations of this model. Once you've done this, it's a lot like creating a hole using the Hole Wizard tool. You go to the Positions tab and you can position the items using a point tool. So I'll position 3 of them down this edge here. Using a center line, I'll then hold them in place. Okay, I'll add some relationships between these. Just make sure they're fully tied in. And then I need to add some dimensions just to hold them in the right position. So having fully defined these now, I can come outside of this sketch by hitting the tick on the left, and then it'll insert those onto the model. So I'm getting towards the completion of this particular design now. The last feature I want to insert is one of the newer features for the sheet metal tools. If we go down to the sheet metal commands in the insert menu, I want to insert a swept flange, which you'll see is just here. So to insert a swept flange, first of all, much like the sweep feature we can insert normally, we need a path and we need a profile. So in order to insert the path, I'm going to do a sketch on this side face of the model here. I want to insert a path that goes around this edge all the way around the model. So I'm going to right click and I'm going to select tangency, which selects all the way around this edge. I can then convert those edges into the sketch that I'm in at the moment, and then just get rid of any of the areas of the sketch that I don't want. So all of these edges just here. Okay, having created that first sketch, I then need my profile, which I'm going to draw on this face. Using my line tool, I'm just going to draw 3 lines. Okay. I'm going to line up these edges. So using the relationships between the 2 endpoints, I'm going to make them vertical to one another. And then I'm going to put in some dimensions to define the size. Okay, so having defined the approximate size of the item that I want to sweep around the model, and having defined the sketch, you'll notice both of these are separate sketches with the profile at 90 degrees to the path, or to the end of the path there. I'm then going to go to insert features, insert sheet metal rather, and select the swept flange tool. So first of all, I need to select my profile in the top box, which like the normal sweep tool. And then I need to select the path around which I want it to sweep. You'll see if I just click, it just selects that single line. So I'm going to go ahead and expand this region and just select Sketch 38 from the design tree. That selects the whole item in there. It hasn't given me a preview yet because, again, that bend radius is still at 90 millimeters. So I'm going to size it down. I'm going to use an overriding parameter of 3 millimeters there. And you'll see then it gives us a preview. The thickness then is still set to 5 millimeters. I want to make sure it's reversed so that it's thickened inside the model. And I can make the thickness slightly smaller if I want to. Again, maybe 1.5 is a little bit small, but 3 mil there should be fine. And that just gives me an edging on the table. Okay, I'll keep everything else at the default values, and then I'll hit the tick. And that just gives me a nice edge onto that table. I'm then going to mirror that over to the other side of the design. So I'm going to go to the plane down the middle. I'm going to use my mirror tool, using bodies to mirror that over. Okay, and then we have one on both sides. So hopefully that gives you a good idea of some of the tools you can use when you're creating advanced sheet metal parts. You'll see here we've got several flat patterns within this design. If we take this one, for example, the swept flange, try and find that in the design tree there. You can unfold that and we should get, there we go, a long flattened out model. So when you select each one of them, they unfold separately. For example, we looked at the leg earlier on. The overall flat pattern of the major body there, again, that should flatten out all the way across. Okay, it just takes a minute when it's first doing it, but there we go. There's that flat pattern. So hopefully that'll be an introduction to some of the advanced tools you can use, like the lofted bends tool or the swept flange, as well as using some of the jog tools and sketch bends. We can just help you in the kind of normal modeling process. Thanks very much for watching. I'll point out some of the future webinars we've got coming up on this one. You'll see that we're coming up with a product design series, the first part of which being modeling of a consumer product, which then we're going to take through several design phases through different weeks and actually cover different areas each week. Okay. So next week will be modeling. It will be mainly sort of surface modeling within this one, but do tune in if that's of interest to you. Thanks very much for watching.